Okay, in 6.1 we're going to review what you know about function notation from Algebra 2, and what we need to do first is just kind of talk about why we use function notation. Function notation is a way to denote the dependence of one variable on another. So when you have, for instance, y equals f of x, that means that y is a function of x, or that y depends on x. If you have y equals 2x plus 1, it's basically saying the same thing as f of x equals 2x plus 1. And but if you, for instance, replace x with 5, f of 5 equals 11 is just a more concise way to say that y equals 11 when x equals 5. Also, since there are many ways to name a function, the most notable ones that you'll see are f of x, g of x, and h of x, for example. You can refer to more than one function in the same problem without any confusion. So let's put this to work. Evaluating expressions. So if I have g of x is equal to x plus 3 squared, that's given to us in example 1, and I want to know what g of 7 is, I'm just going to take that equation, g of x equals x plus 3 squared, and I'm just going to replace the x with 7 because on the left side of the equation the x was also replaced with 7. So if we replace the x with 7 on the left, we must replace it on the right. So from this point forward, g of 7 equals, and we'll just follow order of operations, 10 squared. So g of 7 equals 100. If I were graphing this, this answer would mean when x is 7, y is 100, and so I would graph the point 7, 100. All right, let's try g of negative 9. G of negative 9 is equal to negative 9 plus 3 squared. And so that'll be negative 6 squared. So g of negative 9 is positive 36. In the next part of this question, we're asked to find h of 1. So now we have to change gears to use function h, which is this one above here. H of x equals the square root of x minus 5. So h of 1 is the square root of 1 minus 5, which is the square root of negative 4. And you'll remember from Algebra 2 that this is actually an imaginary number. It's h of 1 is 2i, but for our purposes when we're graphing, we can just say it's not real. Okay, so if you write equals 2i, you won't be wrong, but you can get away with just saying it's not real. All right, f of 5. So now we're shifting gears to a different function. F of x is 4x minus 3. So f of 5 is 4 times 5 minus 3. And we can do that. That's 20 minus 3 is 17. G of negative 1, shifting gears to function g, is negative 1 plus 3 squared. So that's going to be 2 squared or 4. And I like giving my final answer with the g of negative 1 equals 4 so that we have both the x and the y in the final answer, but you don't have to. You can just say equals 4. All right, h of 5 is the square root of 5 minus 5, which is the square root of 0. And remember that the square root of 0 is the number that times itself gives you 0. So that number does simplify to 0. We can take the square root of positive numbers or 0, but we cannot take the square root of a negative number. All right, now we're going to do some function composition. H of g of 0. And I think you also did this in Algebra 2 as well. We're going to start on the inside those parentheses. So h of g of 0, the very first thing that we're going to do is evaluate g of 0. So go to your function g, replace x with 0. So we have 0 plus 3 squared, which would be 9. So g of 0 gets replaced with 9. Now we have h of 9, and we can look at the function h of x. So h of x is equal to the square root of x minus 5. So h of 9 is the square root of 9 minus 5, or the square root of 4. So that's going to equal 2. All right, try f of h of 21 on your own, and pause the video to take time to do this. All right, you should have gotten 13 for that answer. All right, now we're going to try something that's a little bit more general. Instead of having an input value, we're just going to put an input variable in there. So we have g of f of x. So this is the same thing as g of, and f of x is, if you remember, 4x minus 3. So this is g of 4x minus 3. And then we need to think about what g does to its inputs. G of 4x minus 3, actually let me highlight this a little bit differently here. Whoops. Need my eraser. There we go. Okay, so g of 4x minus 3 is 4x minus 3 plus 3 squared. Right, so we've just taken the g of x equation and we've replaced the x with 4x minus 3. So on the inside of the parentheses there, you can see that we can add the like terms together. So that's just 4x on the inside of the parentheses. And 4x squared is 4x times itself, so that would be 16x squared. All right, let's try f of g of x. And function composition is not commutative. That means it matters the order in which you do it. So that's f of, and g of x is x plus 3 squared. So f of x is 4x minus 3. So f of x plus 3 squared is 4 times x plus 3 squared minus 3. And if we want to, we can simplify this. I'm not sure it's quite necessary on this. We'll wait for directions on that, but we could, if this answer is not acceptable, it said go ahead and multiply it all out, then you'd have to do some squaring. X squared plus 6x plus 9. Multiply that by 4. And then subtract that 3 to get a final answer of 4x squared plus 24x plus 33. Judging from the space under that problem, that's not what wasn't the expectation. All right, now we're going to get into something that's just a little bit more involved than things that you've done before in Algebra 2. So now we have a new function that's based on an old function, f. So p of x is equal to 2 times f of x minus 3 plus 1, and we are asked to find what p of 8 is. So what I'm going to do here is on the left side of this equation, I'm simply just going to replace x with 8 so that we have p of 8. Now if I replaced x with 8 on the left side of the equation, I'm going to have to replace it on the right as well. So I'm just going to bring everything else down to this step. So we have 2 times f of 8 minus 3 plus 1. When you are evaluating expressions with functions in them, we need to just follow order of operations, which means that we're going to do the inside parentheses first. So 8 minus 3 is 5. And then this is the part I think that gives the most confusion. You can't do anything with that 5 except take f of it. So once we've done that inner parentheses, you have to recognize that f of 5 is a value. So take f of 5. Now we're going to have to refer back to our menu of what each of these functions means. And you'll remember that f of x is 4x minus 3. So f of 5 is 4 times 5 minus 3, which would be 20 minus 3, or 17. Oh yeah, that's right. We did f of 5 up here in part D. So that's 2 times 17 plus 1 is 34 plus 1 is 35. So P of 8 is equal to 35. All right, let's try J. In J, we have K of x is equal to 5 times G of 1/2 times x minus 2. And we're asked to find K of 2. So we're going to replace the x with 2. And if we replace the x with 2 on the left side of the equation, we need to replace the x with 2 on the right side. So inside parentheses first, 1/2 times 2 is 1. Then function evaluation. What is g of 1? Let's take a look at our menu of functions. G of x is x plus 3 squared. So g of 1 is 1 plus 3 squared, which would be 4 squared or 16. So we have 5 times 16 minus 2. That's 80 minus 2 is 78. So K of 2 is 78. Okay, we just need to follow that process basically. All right, now this next example is asking us to find not function values, but the x values that would produce certain function values. So the first question asks us to find x if g of x is equal to 4. So I'm going to write down the equation for g of x. The equation for g of x is g of x is equal to x plus 3 squared. Now it said that g of x is equal to 4, so what I'm going to do is not replace x with 4, but replace g of x with 4. So we're not doing g of 4. We're doing what x value would produce g of x equal to 4. So now we have 4 is equal to x plus 3 squared. The best way to solve this equation is to take a square root. If you remember, a quadratic equation is going to have two solutions. So that means that x plus 3 on the inside of the parentheses can be 2, or x plus 3 can be negative 2. So x, if we subtract 3, is negative 1, or x, if we subtract 3, is negative 5. So we have a solution set with two values in it, negative 5 and 1. All right, let's try B. Find x if h of x is equal to 7. I'm going to write down the h of x equation. H of x is equal to the square root of x minus 5. And we're going to replace the h of x with 7. And then solve for x. We can solve this one by squaring both sides, and then adding 5, and that'll get us x is equal to 54. Remember that a quadratic equation has two solutions, but a square root equation will often only have one. Next set of problems involve a graph. So we're given a graph of y equals f of x, and we're asked to find f of 2. So keep in mind that the equation is y equals f of x, or f of x equals y if I want to write it that way. So when we look at it this way, and we look at what this first question is asking for, it's telling us that 2 is a replacement for x. So if we want to know what goes on the other side of the equal sign, we are looking for a replacement for y. So just go to the graph and go to the point where x is equal to 2, and you'll find this point right here. When x is equal to 2, the y is equal to 0. So f of 2 equals 0. All right, in B, f of negative 2 is equal to, we'll go to where x is equal to negative 2, which is right here on the graph, and we'll find the corresponding y value is negative 1. If we try to do the same thing for f of negative 4, if you go to the place on the graph where x is equal to -4, it would be anywhere on this vertical line that I'm drawing right now. And there is no point on the graph that goes through that vertical line. So that means that f of -4 is undefined. In D, we're asked to find f of -1 plus f of 3. Well, this just means that we have to find both f of 1 and f of 3, f of -1 and f of 3, and then just add them together. So going to the graph, when x is -1, the y value is -2, and when x is 3, the y value is -3. Adding those together, we get -5. In E, we have 5 times f of 1 minus 3. So first task would be to find out who f of 1 is. And f of 1 is, let me erase some other things on the graph so we don't have all that confusing stuff on there. F of 1 is the y value when x is 1. So that's 2. So we have 5 times 2 minus 3 is 10 minus 3 is 7. All right, try f on your own and pause the video while you do this one. You should have gotten a result of 1 because f of 4 is equal to -2. All right, let's try some that refer to a new function that's defined in terms of the old function. So we're going to refer to this graph of f of x that's above, but there's a new function defined, g of x, that's defined in terms of f of x. So if we take this equation right here, and we're asked to find g of 3, that means we're replacing x with 3. And so I'm going to replace x with 3 on the other side of the equation. So inside the parentheses first, 3 minus 2 is 1. Now we have 5 times f of 1 plus 3. We're going to find f of 1 by looking at the graph of f of x that's above. And f of 1 is 2. So we have 5 times 2 plus 3 is 13. So g of 3 equals 13. All right, you try g of 0. Pause the video while you do this. All right, you should have found that g of 0 is equal to -2. Looking at the next part of this question, C, we see this phrased differently. Find x if g of x is equal to 3. So that must mean that we're replacing g of x with 3. So I'm going to replace g of x with 3 in the equation. So 3 equals f of x minus 2 plus 3. I'm sorry, equals 5 times f of x minus 2 plus 3. All right, now I want you to think about the order of operations that we used in the last two parts of this question. We did the inside parentheses first, subtracting 2 from the x value. Then we took f of that number times 5, and then added 3. If you're trying to undo those operations, you have to undo them in reverse order. So first step is subtract 3 from both sides of the equation. If we subtract 3 from both sides, we've got 0 equals 5 times f of x minus 2. And then we're going to divide by 5. 0 divided by 5 is f of x minus 2. Now, when we get to this point, I want you to think about this question in the following way. Our next step is going to be to try to undo the function f. In other words, our next step should find out what x minus 2 can possibly be equal to. So we want to think of it this way. F of what equals 0? So if we look at the graph above, f of what x value gives us 0? Well, f of -3, f of 0, and f of 2 are all equal to 0. So that means that the inside of the function, which is x minus 2, can be equal to -3, or x minus 2 can be equal to 0, or x minus 2 can be equal to 2. Oops, I've gone a little bit beyond the page there. So I'll just put that below. So if we add 2 to all 3 of those equations, add 2 to both sides, we'll get x equals -1 from the first equation, or x equals 2, or x equals 4 from the last equation. So we have a solution set with 3 values in it. All right, you try the next one on your own. Find x if g of x is equal to -12. Pause the video while you do this. All right, you should have gotten 5 for this one. Once we get to that point where we have that step f of x minus 2 is equal to -3, we're just trying to find f of what equals -3. Since f of 3 equals -3, then that x minus 2 on the inside of the parentheses has to be equal to 3. All right, now this next part involves simplifying rational expressions involving functions. This is actually a precursor for calculus. So we're developing an algebra skill that's going to help us in calculus, and it has to do with finding slope. So you might notice that each one of these little expressions that we're trying to simplify looks like a slope. They look like y2 minus y1 over x2 minus x1. All right, so g of x is equal to x squared plus x. Now I have a minus sign, and g of 3 is equal to 3 squared plus 3. I have to be very careful here, though. Whenever I subtract something that has more than one term, we need to put parentheses before it to indicate that you're subtracting that entire quantity. Now downstairs, I'm just going to bring down the x minus 3. So in the numerator, we have x squared plus x, and then let's just simplify what's on the inside of that parentheses. 3 squared plus 3 is 9 plus 3 is 12. And then you can factor x squared plus x minus 12 into x plus 4 times x minus 3. And from that point, we can grab our handy dandy blue cancellation pen, cancel out those x minus 3's, and what's left is x plus 4. Now, if we're being super accurate about what we're saying about this simplification, is we should really say probably it's x plus 4 except for when x is equal to 3. Because if you look at the original expression, if x is equal to 3, we have g of 3 minus g of 3 over 3 minus 3, which would be 0 over 0. I'm not going to hold you to that because that's not the important part of this skill that we're dealing with right now. But if we're being technical about it, it's equal to x plus 4 except for when x equals 3, because when x equals 3, the original expression is undefined, and x plus 4 is equal to 7. All right, let's take a look at h of x minus h of -5. Function h of x is 1 over x. H of -5 is -1/5, so that'll be minus a -1/5 would be plus 1/5. And then downstairs we have x plus 5. All right, now what we want to do is to simplify this complex fraction, and you'll remember from Algebra 2, when you want to simplify a complex fraction, take the GCF of all the little mini denominators, that is to say all the denominators within each numerator or the denominator, and multiply by their GCF, or I'm sorry, multiply by their least common denominator. So the least common denominator of x and 5 is 5x. Now we need to distribute to this addition on the numerator, and 1 over x times 5x, the x's cancel, and that'll give us 5. 1 over 5 times 5x is x. Downstairs, I'm not going to distribute because you'll notice that we're going to have a factor that will cancel. We have 5 plus x and x plus 5, which are the same thing, and that's going to leave us with an expression, final simplified answer, 1 over 5x. All right, your turn to try. Try C on your own. Pause the video while you do this. You should have gotten a result of x. Since the function value g of -1 was equal to 0, we had a binomial that had a GCF in it that you could factor out. All right, now your turn to try D. This one should have simplified to -1 over 7x. You have to recognize that in the example above, we had x plus 5 and 5 plus x, which are the same thing because addition may be done in any order. Subtraction cannot be done in any order. So, for instance, x minus 7 and 7 minus x are actually opposites of one another. Consider if x is 4. 4 minus 7 is -3. 7 minus 4 is +3. So they're opposites. When we cancel those factors, we're going to get -1. All right, last example asks us to consider a different kind of slope function. So this is just another one that gives us a different way to look at slope. So this one's f of a plus b minus f of a all over, and the denominator would be a plus b minus a. Just take the x values and subtract, but a plus b minus a is equal to b. All right, so we're going to use f of x squared. F of x equals x squared, and f of x equals x squared. So f of a plus b is a plus b squared. F of a is a squared. And then downstairs we have b. Let's just go ahead and expand this. A plus b squared is a squared plus 2ab plus b squared. And then I'll just bring down the minus a squared and the over b. You'll notice that there are two opposite sign terms there, positive a squared and minus a squared. So we'll get rid of those or combine them together to get 0. And you'll also notice that the numerator now contains terms that have a factor of b in them. So we can factor out the b. That gives us 2a plus b over b. Cancel the common factor of b. And the final result is 2a plus b. In this last example, we have f of x equals 4x plus 3. So f of a plus b is 4 times a plus b plus 3. And then we need to subtract f of a. F of a is 4a plus 3. And then downstairs we have b. Let's go ahead and distribute 4a plus 4b plus 3. And then take into account the subtraction or distribute the opposite sign. So minus 4a minus 3. And now when we look at the terms in the numerator, we have 4a and negative 4a. They're going to add up to 0. Plus 3 and minus 3 add up to 0. And we're left with 4b over b, which simplifies to 4. Interesting thing about this one, this was f of x equals mx plus b, which is the equation of a line, and our slope turned out to be 4. So this is an actual way that we can find the slope. Of course, there are easier ways, but this is a nice way that we can find the slope of a nonlinear function, for instance. And that's it for the lesson.